So we're going to start with the remainder and factor theorems. So the the remainder theorem says if a polynomial is divided by x minus c, then the remainder is f of c. Okay? So take a look. This process is called synthetic substitution. So basically, why is it frozen again? Okay, so basically, look at this example 4. It says to use synthetic substitution to find f of negative 2. Until now, if you were asked to find f of negative 2, what would you do? Take negative 2, plug it in here, blah, 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 and find it. We're going to do it in a different way today. So we're going to use synthetic substitution, which is basically synthetic division. So here we're going to put the coefficients of the polynomial. And then negative 2 as is goes over there. All right? So synthetic division will be, so 3 comes down, you get negative 6, negative 14, 32, 28, and then 32, negative 64, negative 58, 116, 107. Right? So this remainder, believe it or not, is f of negative 2. So if you don't believe me, let's do it the old way. F of negative 2 is 3 times negative 2 to the 4 minus 8 times negative 2 cubed plus 4 times negative 2 squared plus 6 times negative 2 minus 9. And so what is this? That's 3 times 16, right? Minus 8 times 8 plus 4 times 16. 4. Minus 12 minus 9. And all of that is 107. Okay? So do you see how much cleaner this is? Right? Oh my gosh, my voice. Okay. So, when you find, if you do this to find f of a value, f of negative 2, and you get a remainder, right? Well, if the remainder is 0, that means it was a factor, right? Well, in that case, if you have a number where the remainder is 0, and if you find f of that number, wouldn't you just get 0? Right? So do you see how it totally works with each other? Right? Yeah.
Just one thing about what you did in the old way of the substitution. Wouldn't it be for negative 8 times negative 2 to the third?
Oh yeah, it would be positive. Sure.
Yeah.
Yeah, but then it all works out. Yeah. Oh, okay. Okay, so use the factor theorem to determine if the binomials are factors of this. So go ahead and do that. So you're going to do synthetic division.
Can you use one division or synthetic or only synthetic?
You can use both as long as you get remainder 0. It doesn't matter. So go ahead and do it. I'll give you guys 2 minutes to do that. So they are both factors. All right? Okay. So here we go. We're going to solve each equation given that, we're given one of the roots. So, you know that -1 is a 0. So when you do synthetic substitution, you should get what? 0 for the remainder. So let's go ahead and do that. So -1. And then here we're going to get 15, 14, -3, -2, right? So 15 comes down, -15, you get -1, 1, -2, 2, 0. Good, that's what we expected. So now let's rewrite the polynomial. This is a 0 of -1. That means the factor associated with that would be what? X plus 1. And then from here I get 15x squared minus x minus 2 equal to 0. I wish I had a voice so I could like shout about how exciting this is, but is it? Sucks. Yeah. Okay, so x plus 1, let's factor. Okay, I'm going to really challenge you to factor this by trial and error now. Okay? I know, it's a big thing. So you can either do 15x and x or 3x and 5x. I like to go with the broken up ones first, right? So let's just check. 3x, x. Two numbers that multiply to 2?
3x and 5x.
Oh, 5x. That would have never worked. Come on. Why want an erase? Oh no, we're doomed. Oh no, it froze. Are you kidding me? My entire computer froze. So 3x and 5x, and then we need two numbers that multiply to 2, which is 1 and 2. Okay. Okay, so 5x. So here, let's say you do 1 and 2, right? Now the outer terms give you 15. I'm sorry, the outer terms give you 6x. These give you 5x. You can definitely combine 6x and 5x to get -x, right? You would have to make the 6x a negative and this a positive. So x equals -1, x equals -3, and x equals 2/5. Those are the answers. Right? So again, previously we would never have been able to solve that by hand, but now we totally can given these new theorems and tools. Okay? All right, should we do another one? Yeah. Yeah.
How do we know from the equation if it's not a function?
If it's what?
Not a function.
It will always be a function because it's actually, it will be.
Oh.
Yeah. So here, we're going to solve this given that -1/3 is a root. So -1/3 goes out here. And then we have 3, 7, -22, -8. 3 times -3 gives you -1. 6, -2, -24, 8, 0. If you don't get a 0 there, you've made a mistake because, it's a root. Okay, so here we go. What are the functions here? So x minus x plus a third, and then 3x squared plus 6x minus 24.
Would it not be 3x plus 1?
Yes, it would be. So equals 0. So now look, we can't really leave this like this. So if you pretend to multiply through by a 3, this gets multiplied by a 3 and it becomes 3x plus 1. I know you did that last year. And then so my shortcut is I just, always just put the 3 over there. So now I have 3x plus 1. And then from here, I'm going to factor out another 3. I'm going to put that out here. So we get x squared plus 2x minus 8 equals 0. So we get, how is that going to factor? X plus 2, x minus 4, nope, other way. X plus 4, x minus 2. So x is negative a third, 2, negative 4. All right, questions? Yeah.
Why would you multiply the 3 back into the 3x squared plus 6x minus 24?
Wait, what?
On the first step,
Uh-huh.
wouldn't you multiply it?
Oh.
You multiplied it in the first parentheses. Why wouldn't you do the second one?
You only multiply into 1,
Okay.
right? Because if you just have numbers, right? 3 times 5 times 7,
Yeah.
you wouldn't do 3 times 5 and 3 times 7, right? You would just do it once. Yeah. Yep.
What did you do with that?
I'm sorry, find that k value so that the remainder is 0. Okay, so same thing, right? We need to find a remainder, so divide. So negative 2, 1, 18, k, 4. Those are the coefficients. 1, 16, negative 32 here. So when you add, it's k minus 32. And then here you get negative 2k plus 64. So the remainder is negative 2k plus 68. But we want the remainder to be 0. So we're going to set that equal to 0. And we're going to get k equals 34. Ugh, I keep writing 64. All right? And that's it. That's the end of that lesson.
Yeah, right. Can I just do it like this? Or just write down what the numbers should be and then
Now we
go.
have 30 minutes to do it.
Oh.